Hi, welcome to this special video, and it's really about the chemistry calculations behind Scoville Heat Units. Now, when I say that, I've actually got the Food Sense Generation 4 in front of me. I'll be using a quick demonstration of this, and the Food Sense Generation 4, the way we've got it configured at the moment, it's giving the results in Scoville Heat Units. If you're not familiar with this we're going to be measuring a chili sample. But that said, it gives us results in Scoville Heat Units, and it also gives it in micromolar as well. I think it's just a historical accident that we're giving it in micromolar. We were giving it in micromolar ppm and Scoville Heat Units. Most of the industry is actually using Scoville Heat Units. I've only come across one HPLC test house where they gave the answers in milligrams per something like 100 grams or something like that, which is quite unusual. Maybe other places would do it in ppm, but most people are actually doing it in Scoville Heat Units. That said, let me go forward and do this quick demonstration. So I'm just going to go back to these slides really quickly. So I will be doing a quick test of a chili sample, but really it's more about doing some calculations for you as well. It's probably worth saying that with Food Sense Generation 4, if you're an actual client, you get personal online training. We do weekly webinars. Maybe sometimes we throw out a quick video like this in particular just to help a particular client. We will have a monthly webinar. It's probably worth saying that on the 29th of August, I'll put it underneath the video, we will be having a webinar and demonstration. It's probably worth saying that that happens every month, so just click the link underneath the video. With that said, these two of these images are slightly blurry, but I'll do a real demonstration now where today the Food Sense Generation 4 will measure the hotness of a chili sample, and it'll give the results up in micromolar and Scoville Heat Units. Now, micromolar is a very chemistry friendly unit. So, you know, if you've done a high school chemistry, you've maybe talked about molarity. If you've done degree chemistry, you definitely did talk about molarity. I'm not trying to be, it's a unit that chemists like. It tells us about the ratio of molecules in there. It's not maybe a very friendly unit outside the immediate community of chemistry, but that said, I'll talk about how we go from micromolars to Scoville Heat Units. Now, Scoville Heat Unit is also a very unusual unit. I mean, this is an organoleptic unit that was invented in 1912 by Wilbur Scoville. We have units out there called SI, Scientific International, SI units. Scoville Heat Units is not an SI unit. It's a really bizarre unit, and it's just a historical hang-up in the world of chili testing. That said, let me do a quick demonstration for you, and then maybe I'll go through some calculations as well. So I'll whip out a Food Sense Generation 4 sensor now. I just want to get a result on my phone and then talk about some of the calculations behind these results. So I'll put that on like that. Just realised luckily I've got my pipette. This demonstration is not so much about testing this sample, it's more about just getting a result on my phone so I can do a quick show of a calculation for you. But one of the joys of Food Sense Generation 4 is it's actually quite quick to do a test. Just give this quick name. Tab. Sorry, I'm just thinking. I'm just thinking whilst typing, and that's not necessarily a good thing. Go to assay and start measurement. Okay, so that's running now because I just want to get results on my phone. I'll show the results on my phone. Then I'm going to show you the results in the cloud, and I'm then going to show you a quick spreadsheet calculation. So at the moment, there's a progress bar on this. It's progressing. I put 50 microliters onto the sensor. When that result, when the sensor's done its work, the meter will give the results to the phone, and I'll show you a few more things. So let's see what's going on here. Okay, so I'll change screens just for a second, just so you can see this a bit more clearly. Right, so it says 587 micromolar, giving me a Scoville Heat Unit of 2,690. So that's 587 micromolar, giving me a Scoville unit of 2,690, and it says upload complete. So what I will do is I'm just going to quickly go to my one of my screens here, and I'm just going to refresh. So we have something called Julie. Every time we do a result, the result actually gets sent to the cloud. So in the cloud, I actually have my if you look up here, 580. Now this is quite small. I might be able to just zoom in a little bit. So let me just zoom in a little bit. So I said 587 on the app. On the app, it said 587, but you can see here in the cloud, it's actually 586.683. It's a bit ridiculous. You don't need 3 decimal points, but that's what the cloud does. But when we show it on the app, it's a much more rounded number. And then we've also rounded the Scoville Heat Units as well. So the Scoville Heat Units on my phone says 2,690. You've got to understand that, you know, in the cloud we say 2,687.008. It's just the app rounds it because we want people to have a nice user experience. And whether you report a Scoville Heat Unit as 2,690 or 2,687, it really doesn't matter. It's not even a sort of, I'm just doing some in my head calculations here, but it's probably not even 0.001% difference. With that said, now I'm just going to do a quick calculation. So I'm just going to drag on a spreadsheet real quick. So let me just take that result, which was 587 micromolar, 587, right. So 587 micromolar, the first thing that the app is actually doing is converting it into molar. So micromolar into molar, just divide by a million. Then we do into grams per litre. So just take the molar concentration and times it by the molecular weight of capsaicin, which is 305.418. Then because that's grams per litre at that point, when I've done that, we then divide that answer by a further 1,000 because there's 1,000 grams in a litre, which leaves me with, you know, if I can, 0.0017928 grams per gram. But because I want to get essentially into ppm, I should, I'll make a little correction here actually, that I times the answer by 1 million because that tells me then that's how many micrograms per gram there actually are. I'm just going to put a quick bracket in here because that's really also the unit for ppm. Whoops a daisy. ppm, yeah, good. And then we times that by 15. You've got 2 choices in life. You can times it by 16 or by 15. The AOC have originally started off with 15. Now these days they may have gone to 16. It really doesn't make much difference, but this is how you get from ppm to Scoville Heat Units. And you can see that actually we're on the app. We want to give people a very easy, clean answer. So actually it's 2,689, but we want to give people a much cleaner answer than that. So in fact we rounded it to wrong screen, 2,690. But you can see that if you actually calculate it out sort of through a spreadsheet, then you get to 2,689. So this was a slightly different, I want to say webinar, but I would say almost a video that I was really just talking more about the calculations that the app is actually doing in the background. You know, we can go from micromolar to ppm to Scoville Heat Units. I'm going to do all sorts of videos about Scoville Heat Units. It's such a strange unit. I think it sometimes makes things, it exaggerates errors, if I can put it that way, but that's for another video. With that said, if you've got any questions about Food Sense Duration 4 and the ability to quickly measure Scoville Heat Units, and I would just change it here, then please don't hesitate to contact us. Okay, thanks very much.